Recognizing quadratic patterns. Quadratic patterns can be found in real life. Let us investigate a real-life problem which will lead to a quadratic pattern. Eugene is in a math class of 10 learners. On the first day of his class, his teacher asks everyone to shake hands and introduce themselves to each other. After completing the introductions, the teacher asks Eugene how many handshakes has been exchanged. Can we help Eugene answer this question? Solution. Let us make a table to help us keep track of the handshakes as they happen. We will use tally marks to help us keep count of the number of handshakes. Let n denote the number of learners, and Tn denote the total number of handshakes. When there is just one learner in the class, there are 0 handshakes. So, let us continue with 2 learners and work our way through. When there are 2 learners, the total number of handshakes is 1. When the third learner joins, the total number of handshakes increases to 3. When the fourth learner joins, the total number of handshakes is increased to 6. When the fifth learner joins, the total number of handshakes increases to 10. When the sixth learner joins, the total number of handshakes increases to 15. If there are n learners in the class, the number of handshakes is Tn. Can you recognize a pattern in the number of handshakes? We know that in a linear number pattern, the difference between consecutive terms, p, is constant. Let us investigate this number pattern and calculate the difference. We can see that the difference of this pattern is not constant. In fact, it is actually forming yet another sequence. We call this first difference. We now calculate the difference between the first differences. We find the second difference to be 1 and constant. We call this second difference. If the second difference of a sequence is constant, the pattern is quadratic. This is the signature of a quadratic pattern. We know the first 6 terms of this number pattern. To calculate the number of handshakes in a class of 10 learners, that is, when n is equal to 10, we simply extend the pattern. We extend the pattern by repeating the constant second difference for the next few terms. We now add the second difference 1 to the 6th term of the first difference, that is 5, to calculate the first difference of the 7th term, which is now 6. Similarly, we work upwards and add the first difference 6 to the 6th term of the linear number pattern, that is 15, to determine the 7th term, which is 21. We calculate the next few terms by repeating the steps until we calculate the 10th term. Thus, the total number of handshakes in a class of 10 learners equals 45. This problem of handshakes that we just saw has been used for introducing the concept of quadratic patterns. In reality, no one seriously needs to count handshakes. However, there are many genuine real-life problems connected with networks, for example of roads, internet connections, etc., that exhibit similar characteristics. To answer questions related to interconnectivity or capacity of networks, we apply the concept of quadratic growth patterns. For example, notice that a single phone can make no connection, while 2 phones can make only 1 connection. 5 phones can make 10, while 13 phones can make 78 connections. As the number of phones increases, the number of possible connections increases faster and faster. No wonder that the cell phone companies are trying to sell more and more phones to increase the number of connections and hence their profits faster.
Need more help? Subscribe to our channel. Can't wait that long? Ask Mesky to help you and let the math finally start mathing.